In this video, let me consider one numerical on loop analysis. Find voltage across 5 ohm resistor for the network shown below. This is the given circuit. We are supposed to find the voltage across this 5 ohm resistor. So this problem can be solved either using loop analysis or node analysis. I will try to solve this using loop analysis. So this is the given circuit. So before applying KVL to the loops, I will try to convert this current source which is parallel with resistor into a voltage source. Let me convert this into voltage source. So we know that V equal to IR. So I is 9, resistor value is 4. So the magnitude of voltage source is 36 volts. So I will try to replace this current source by voltage source. So head end of the arrow should be positive and this is negative. Magnitude of this is 36 volt. Now 4 ohm is connected in series with this. So this 4 ohm is connected in series. Rest all things I will draw as it is. So this is 2 ohm. We have 5 ohm. Here we have 100 ohm. This is 20 ohm. And here we have 4 ohm in series with voltage source. This is 4 ohm and this is 12 volts. Now let me assume the loop currents. Let current through this loop is I1. Let current through this loop is I2, and let me assume current through this loop is I3. So here I1, I2, I3 are loop currents. So in loop analysis, we need to apply Kirchhoff's voltage law to individual loops. Now let me apply KVL to loop I1, that is apply Kirchhoff's voltage law to loop I1. So that is, let me start from the voltage source. Keep voltage source on left hand side. 12 is equal to voltage drop across 4 ohm is 4 into I1, that is 4 I1 plus voltage across 2 ohm is, here current I1 is flowing opposite to current I3. So I can write 2 I1 minus I3, because in 2 ohm resistor both I1 and I3 are flowing. I1 is opposite to I3, so it is I1 minus I3, plus then current flows through 100 ohm resistor. So in 100 ohm resistor both I1 and I2 are flowing. So we supposed to, the voltage across this is 100 into I1 minus I2, as I1 and I2 are opposite to each other. As we are in loop I1, first I1 we should write I1 minus I2. Let me simplify. It is 12 is equal to, we have 4I1 plus 2I1 minus 2I3 plus 100 I1 minus 100 I2. Or I can write, simplify this as 12 is equal to, here we have 4 plus 2 plus 100, that is 106 I1. Next let me write I2, that is minus 100 I2 minus 2I3. Let me call it as equation 1. Now let's apply KVL to loop I2. Apply KVL to loop I2. So here we can see that in loop I2 there is no voltage sources. So we should write 0 is equal to, let's start from here. Voltage across 20 ohm is 20 I2 plus voltage across 100 is 100 into I2 minus I1, 100 I2 minus I1 plus voltage across 5 ohm is I2 minus I3, 5 I2 minus I3. Let me simplify this. 0 is equal to 20 I2 plus 100 I2 minus 100 I1 plus 5 I2 minus 5 I3, or I can write 0 is equal to minus 100 I1 So here we have 20 plus 100 plus 5, that is 125 I2, and I3 is minus 5 I3, minus 5 I3. Let me call it as equation 2. Now apply KVL to loop I3, that is apply KVL to loop I3. So here start from voltage source, that is 36 is equal to voltage across 4 ohm is 4 I3 plus voltage across 5 ohm is 5 into I3 minus I2. 5 into I3 minus I2 plus voltage across 2 ohm is 2 into I3 minus I1. 2 into I3 minus I1. Let me simplify. 36 is equal to 4 I3 plus 5 I3 minus 5 I2 plus 2 I3 minus 2 I1. Further I can simplify this as 36 is equal to, that is minus 2 I1 I2, there is only one term, that is 5 minus 5 I2, and I3 is 4 plus 5 9 plus 2 11, that is 11 I3. Let me call it as equation 3. Now we are supposed to solve equation 1, 2 and 3, that is solving equation 1, 2 and 3. We get, so to solve these three equations, choose, go to the mode, choose equation mode. In equation mode we have three equations, choose option 2. So here we have to feed the values. So first row is with respect to first equation. Here coefficient of I1, I2, I3 and 12 we have to feed. So coefficient of I1 is 106, that is 106, press on equal. So B is nothing but coefficient of I2, that is minus 100. Then C is nothing but coefficient of I3, that is minus 2. Then D is nothing but this value, that is 12. Similarly, here we have minus 100, that is minus 100. Next we have 125. Next we have minus 5. And here D value is 0. Next in third equation, coefficient of I1 is minus 2. Then we have minus 5. Then we have 11. And we have 36. 36. So press equal. So here X is nothing but I1. So I1 is 1.411. So I1 is 1.411 amp. So I2 is 1.294. I2 is 1.294. Then we have I3. So press equal. So I3 is 4.117. I3 is 4.117. So now we have to find voltage across 5 ohm resistor. That is, assume that current is flowing in this direction. So voltage across 5 ohm can be represented as, voltage across 5 ohm is nothing but 5 into, so here in this direction I2 is flowing, that is I2 minus I3, that is voltage across 5 ohm is 5 into I2 minus I3. So I2 value is 1.294, 1.294 minus, we have 4.117, that is minus 4.117. So simplifying this, we'll get V5 is equal to, so here we have 1.294, 1.294 minus 4.117 into 5. Press on this. So this is minus 14.115. Minus 14.115 volts. So this is the voltage across 5 ohm resistor. Thank you for watching.